Hello everyone, thank you very much for joining us. Today my special guest is Thomas Vitale, author of Cloud Native Spring in Action, expert in domain, and I'm very happy, Thomas. Thank you very much for joining this discussion, and I hope we can learn a lot from you today.
Yeah, I'm happy to be here, and thank you for inviting me. It's always a pleasure to chat about Spring.
Tell me, let's start a bit with cloud native because I hear this word cloud quite a lot today. And is it for already more than a couple of years? I think it's a hype on cloud. All the apps are on cloud. It came with a lot of changes, and you tell people a lot about these changes in how you think the architecture of your applications and even the development of them in your book, Cloud Native Spring in Action. And I want to hear from you. What do you think? Is it still cloud is still the future? For how long? And what should we expect from this perspective?
Yeah, I like to start by distinguishing between cloud and cloud native, because they're buzzwords. Like as all the buzzwords in our domain, we start using them, but then every person you ask about, they have a different understanding or a different meaning for those words. So for me, it's always interesting to find out like what is the meaning, or at least agree on a shared set of understanding of what we mean. And actually the first chapter in the book, it's all about that, like definitions, defining what is cloud native. And in that regard, I really like the way that Cornelia Davis, the author of Cloud Native Patterns, put it, because she says that the cloud is the where, the place where the computation happens. Cloud native is the how we build applications. So in other words, cloud native is all about architecture. It's an architectural approach to software development. And of course, it's oriented or aimed at leveraging cloud infrastructure and cloud capabilities. But actually, you don't need the cloud to make an application, to build an application using cloud native patterns, because cloud native is all about building resilient, scalable, and secure applications. And you can actually use those techniques even if you're not in the cloud. And that's one of the techniques or tricks. Like maybe you want at some point move to the cloud, but you can already now, even if you're on a more traditional infrastructure, adopted architecture, because it gives value even if you're not in the cloud.
So cloud native is, if I heard it right, a set of techniques, pattern, procedures to define your architecture in such a way in which is applicable to the cloud, in which it makes sense for the cloud. But you can also apply these patterns even when you do not necessarily deploy your app to the cloud. And which would be the advantages in that case when you design your app, but you don't deploy it in a cloud, but it's cloud native?
Well, of course, it really depends on the specific use case, but some patterns when we talk about cloud native applications are around the way that we configure them, that we expose functionality. So when we look at the API design or how we can configure them at runtime, the idea that we don't want to mix up application and configuration and secrets, we want to keep them separate. So we have a lot of different aspects that can benefit any kind of application, really, when we look at an enterprise scenario, even if you're not necessarily on the cloud. And something I'd like to mention also is usually cloud native is associated with containers, but you're not required to use containers, because you can use a cloud native architecture even without containers. So that's not a requirement.
The containers are just an approach, but that doesn't mean that you don't want to like choose to use virtual machines instead directly. No?
Yeah, you can use that as your deployment target, of course. Yeah.
And I see that you discuss here about resilience, security. In your book, I see a lot of references to also non-functional requirements of an application. How much does this relate to cloud native in general, or maybe to the cloud?
Yeah, so there is one concept around cloud native, which is the 12-factor app, which is this strategy or these 12 principles to build applications that came from Heroku. Back then, Heroku is a famous cloud platform, and they came up with these 12 factors in order to help developers build applications that could run in an easy and effective way on top of their platforms. And a lot of those requirements are actually not affecting the functionality of the applications, but it's more about those non-functional attributes. So again, the idea of keeping the configuration outside your code, for example, we don't want to rebuild our application multiple times in our path to production. But if we build it at the beginning of our CI/CD pipeline, we want to keep the same artifact all the way because that's the one we certified, is qualified. So if we want to change the database URL, we don't want to rebuild the application, for example. So we want to configure that from the outside. Or perhaps the idea of stateless applications, because they're simply easier to manage. So we try to push the state down to specialized services like databases to keep the state, so we can scale our applications without problems of, what do we do with the state if the application instance suddenly terminates? What about the state? How do we distribute the state if we have more instances? Because of course we need high availability. So there are a lot of these aspects are around the non-functional requirement of an application or in general of a software system.
Okay, but your book in the end is not only about cloud native, it's cloud native Spring. So let's go a bit into the other direction of discussing Spring, which is, I think, one of the most impressive frameworks in the Java ecosystem today. How much does Spring help a developer in building cloud native applications?
Well, Spring Boot is a great choice to build cloud native application. It's one of the use case, and it's a great framework because it can really help developers in different scenarios or in different use cases, cloud native being one of them. And with Spring Boot, we already get a lot of those factors that I mentioned earlier, or patterns already built in inside the framework out of the box. For example, the externalized configuration feature is already part of Spring Boot, so we don't even need to think about it. It's something that is built into the application itself, or the idea of having standalone applications that we can run without any external dependencies. And Spring Boot made the fed jar or self-contained jar popular. So suddenly we don't need anymore an external web server like Tomcat to deploy the application on, but we can simply package the Spring Boot application as a jar file and run it on the Java virtual machine without needing any intermediate middleware. So a lot of those concepts are actually part of Spring Boot and a lot of the libraries that are part of this ecosystem. And then on top of that, we got Spring Cloud that even extended those capabilities by implementing a lot of different concerns that we really need to consider when building for the cloud. For example, service discovery, load balancing, configuration.
And Spring Boot 3, I think, which was just released a few months ago in November 2022, it came with the possibility to build native applications out of the box. I think that's one of the points that will in the future help us a lot in writing cloud native applications, isn't it?
Yeah, and that specific feature also helps with one use case of cloud native applications, or one category, which is serverless applications or functions. So the idea of relying on a platform that can take care of deploying and scaling the application by itself without us having to manage the servers or looking into capacity managements to scale it. And the good thing when we talk about serverless is that if there's no user using the application, there's no event to process, request to process, then it doesn't make sense to keep even one instance alive. We can just shut them all down, what we call scale to zero. And then if a request suddenly arrives, then the platform will spin up one instance of the application. And that's why it's really revolutionary, this approach based on GraalVM that now Spring Boot 3 supports out of the box, because we can build a native executable that has an almost instant startup time. Because in Java, we always had these issues that the startup time is low because we are not working directly with machine code, but we use this intermediate code called bytecode that then at runtime, the Java virtual machine dynamically compiles into machine code that then is executed on Windows or on macOS, on Linux. Instead, with these native executables, we compile the Java applications directly into machine code. That's more memory efficient, and it's faster starting up because there's no dynamic compilation happening. Of course, there are trade-offs there, because in order to obtain that, we have longer build time. So we need a trade-off, and we need to consider the use case. For example, for serverless and functions, this is a great fit for GraalVM native images.
So if I'm a developer and I now have an application already which has been built over, let's say, Spring Boot 2.6, I don't know. I definitely want to upgrade it to Spring Boot 3. Should I also consider changing my pipelines to build natively the application, or should I keep it the way it is now?
I think it's really great we have this option, but it doesn't mean that we have to use it all the time. So it has to make sense. So if you don't need the scale to zero, if you already own your infrastructure, so you're not looking for further resource optimization, it might not make sense if adopting this new way of compiling the application requires too much work for you, because Spring provides out of the box this support for all the Spring libraries and third-party libraries that are part of Spring Boot. For example, Tomcat is one of the, or Jackson. We get that support out of the box, but then we have all our code that perhaps is not compatible because there are some dynamic features in Java, like reflection, dynamic proxies, that we need to take care of. Like, in order to compile it to native executable, we need to provide additional configuration. So it really depends on the use case. But if like for people running Spring Boot 2.x, I would recommend, before trying to upgrade to Spring Boot 3, to first upgrade to Spring 2.7.
Okay.
In general, because it's a better migration path. And then if there's interest in these capabilities with GraalVM, I would say, yeah, try it out. I think it's good to familiarize with this additional feature or additional capability, and then figure out if it's a good fit based on the use case.
But at some point, you'd still recommend probably ending up with Spring Boot 3. I mean, you just as an intermediary step, you'd say do upgrade to Spring Boot 2.7. That will make life a little bit easier because you will have to upgrade less things, change less things, have the application running on Spring Boot 2.7, and then upgrade it later to Spring Boot 3. That would be your strategy.
Yeah, and I recommend using already Java 17 with Spring Boot 2.7, and also like Spring Security, for example. There are some changes that have been already introduced as optional in Spring Boot 2.7 that might help, getting them done already there and before taking the leap. Yeah,
you're totally right. I think with Spring Boot, with Spring Security, there are a lot of changes that are breaking. So if you do upgrade, then you have to really change your code, like the web security configure adapter class. And also, I think in terms of persistency, because that's one of the other topic that you touch in your book, and maybe you can tell us more about persistence as well. If you upgrade to Spring Boot 3, then you need to change all the package names to Jakarta. So they are.
Yeah, that's why it's a good idea to move first to 2.7 and get the upgrade to Java 17 and the rest, like Spring Security, done. And then when moving to Spring Boot 3, then there will be this additional migration with Jakarta. So what happens is that all the old Java EE modules, the package names have been renamed from javax.something to jakarta.something. So if you are using Spring Data JPA, for example, instead of having javax.persistence.entity, if you're using the JPA entities, then we're going to have the Jakarta namespace. So that might require some time. It's mostly search and replace, really. So IDEs like IntelliJ actually provide some help in doing that automatically, or you can use a tool to do that. There's also a Spring Boot migrator library, an experimental library to help in doing these migrations.
By the way, in your book you have discussed also persistence. How is persistence changed, or how do you change the way you architect the apps in terms of the persistence layer if you want to approach them in a cloud native way? And how does Spring help with that?
Yeah. So I cover a few different aspects of data persistence in the book. One, of course, is the most common. It's talking with a relational database. Make an example with Postgres, and Spring Boot offers wide support for that. There's the Spring Data JPA project, which works on top of Hibernate. That's of course a very popular and very powerful framework. But we also have another project called Spring Data JDBC that I cover in the book, which is a most recent addition compared to Spring Data JPA in the Spring ecosystem. But it's really good when talking about cloud native applications or in general microservices, because it doesn't offer all the functionality of Hibernate, but also it's very focused on domain-driven design approach. So the concept of of repositories, of aggregates. So it really depends on the use case, and it's great that in the Spring ecosystem we have different choices based on the use case. And that's for relational databases. It changes when we work with cloud native because we want to be more, at least not be very specific on the way we connect to a database, but use some standard interfaces. And again, having this external configuration, we really want to be able to switch database. So when we move from development to staging to production, just by perhaps updating an environment variable or passing a different configuration from the outside. And also something else I cover in the book that I really like is test containers. I think it's one of the great additions to the Java ecosystem in general in the last few years, because containers really revolutionized everything. But in terms of testing, I really love test containers, because like data persistence, for example, we would test the data persistence layer using an in-memory database like H2, but that's never 100%. Yeah, like for Postgres or Oracle, it's much better to test against the real database. But that was really expensive to set up and not really easy or convenient to have it as part of an automated test. But with test containers, we can add this extension to JUnit and just have this library spin up lightweight containers as part of the test execution, so we can test against the real PostgreSQL database. So we have more reliable tests, and that was really amazing.
The concept is indeed too smart, so I love it as well. I mean, if we came with the idea of having containers, which will spin up, like you can put them down, put them up, then why not having some real stuff that you can use for test, while still using, as you say, in-memory databases? And yeah, indeed, those containers, and I read about them in your book, they're really, first of all, a very smart idea, then an excellent tool that any developer should take into consideration when building their application. And also about apps in general. So you discuss reactive approach. Where is this a fit in cloud native applications?
Yeah, the reactive approach is based on there's the reactive manifesto defining what are the principles or the ideas around this concept, and these ideas really fit well into the cloud native approach, because it's all about making applications scalable, resilient, and in a way that the processing happens asynchronously in a message-driven approach. So the reactive support in Spring Boot is great, and in general, it lets you write more scalable and more resilient applications because the programming model is different. I think that as Java developers might seem very much different, because it's really, we have to think in a very different way compared to what we are used to. We used to have a more imperative approach. We are used to work with threads. We use threads to store data, but in a reactive context, all computations happens asynchronously. But that's also the benefit of it, because suddenly we don't have all those resilience issues about threads blocking or threads being too busy. And a particular approach that comes from the reactive streams specification is that any kind of data in our application can be handled via a common API. So I can combine fetching data from a database and events from a message queue and requests from an HTTP API all in one stream. So, and I can apply all these resilience patterns on all of them. And it's a very different concept, but really, really powerful. And that's also why I decided to cover it in the book, because it really fits the whole idea of moving to a cloud native approach in order to enhance scalability and resilience of an application.
But would that be mandatory, or would you see it sometimes in a part of your system, sometimes you just continue using REST or GraphQL or whatever you, or do you think that reactiveness is something that you really have to apply everywhere?
I think also in this case, it's great to have the option. I wouldn't say that we should use it everywhere, but only where it makes sense. And in particular, I like for new projects to start working with it. But besides these benefits like resilience and scalability, I really like the programming pattern, like the way to program with Reactive and the way I can combine into these streams different operations and operate on data. So I guess it really depends on the use case. Yeah, I don't have a general rule to share. It has to make sense. Also looking at the team, what are they comfortable to work with? Because it's important that we also consider that part, since it's something new, at least in the Java world. But perhaps for a developer coming from JavaScript, it might look quite familiar, because in JavaScript, we've been working in a reactive approach for several years. So depending on the background, some developers might find it really difficult to get started with Reactive, and other developers maybe don't even notice it, because if they work with RX JavaScript in the front end, then it's the same pattern, it's the same approach.
Yeah, they are used to it already.
Yeah, and on top of that, Spring Boot, or in general, Spring provides the same programming model in both the imperative and reactive stack. So it becomes more familiar and easier to switch between the two stacks, because it's the same approach. Like data repositories in Spring Data, we get the same concept in both places, or the REST controllers, we have the same concept in both places. So the Spring really helps bridging the gap between these two different programming models.
Yeah, so at least from a structural point of view, you don't have to like learn something new, but and then you only apply the new functional way of thinking, but it's still easier and better than changing everything from scratch.
I wouldn't go and rewrite an entire application just because reactive is cool. Like there must be a good reason like to do that. Yeah.
Cool. Only one more topic, Thomas, and then I think we can conclude our discussion. Still related to your book, I see that you stress a lot on observability and monitoring also. How much important is this for a developer or architect to take into consideration from the beginning?
Yeah, I think observability is extremely important, and probably we are going through the same process that a few years back we went through with security, that we realized, oh, wait, we should think about security a bit early in the software development lifecycle and not just wait before putting it in production. And the same is for observability, because it started with, okay, now we have the application in production. How can I know what is going on? And of course, that's great. We want to do that in production. But we should think about observability from the very beginning, not just because then it's easier to plan a good and efficient observability strategy, which metrics we want to expose, do we need distributed tracing, but also I think because it's really, really helpful as a developer, if you're working on a distributed system, to get observability in place. Because maybe I have a distributed system with, 10 applications. I'm working on one of them. I would like to see the flow of requests perhaps through the system while I'm developing, or get the logs in a nice way without going to the terminal and correlate all this data, logs, metrics, traces. It's been really useful also as part of development and debugging. So I wouldn't wait until late to do that. And it's great because with Spring Boot, we get a lot of that out of the box because we add Spring Boot actuator and we get a lot of different endpoints exposed out of the box, including metrics that we can use, super useful. Now in Spring Boot 3, we also get tracing, part of the core framework. So everything is easier with Spring Boot also to start doing that as part of development and use it, not just for production, but take advantage of that from the beginning. Like if we have the setup, let's use it as much as possible because it's really useful also to better understand what's going on in the system.
Cool. Thank you very much, Thomas. Guys, I've learned a lot. I hope that you've learned a lot as well. But mind that this subject, observability, resilience, security, Spring Boot, Actuator, whatever we discussed there during just a few minutes is just a small part of what you find in Cloud Native Spring in Action in Thomas' book. So I do recommend you all read the book. It's a must read for any Java developer, and it will really help you enhance the way you write your applications. Thank you very much, Thomas, again for being here and for.
Thank you for inviting me.
Cheers.